x. Then I want to make a triangle. What substitution do I want to make here?
I think
I just only know how to deal with my triangle.
I think it's like x. It should be 3 secant.
So I want to say a is equal to 3, and I want to say x is equal to a secant theta. But if I do that, I substitute a secant theta into this x, I'm left with this pesky 81 here. If it was on the outside, that would be too bad. I could just move it out of the radical, but it's only affecting x squared. So instead what I'm going to do is I'm going to say 81x squared is equal to 9x all squared. Does that make sense?
Yeah.
Mm-hmm.
So then I can say that 9x is equal to a secant theta. Means that this side would be a, side would be 9x, and this side would be 9x squared minus a squared. Not super visible, but and then it is looks exactly like the radical I'm wanting to replace, so that's good. And so from this, knowing that I want to look for this radical, and I want something not in terms of x, so I can make everything in terms of theta. So I want something
I want
with
it to be
on top, stay on the bottom.
opposite over opposite over adjacent.
So that would be
81x squared minus 9 over a.
yep. And what function is that?
Tangent.
Tangent.
So a tan a equals the root of 81x squared minus 9.
You know, is equal to
Wait, Sarah, are you in the middle of collaborating with some people right now?
x squared.
Wait, what?
And say again?
I heard someone say, "Are you in the middle of something full of people?"
I'm sorry. I was on the phone with my husband.
Oh, okay. I thought someone was like saying that to people
Oh,
here,
no.
and I was like, I'm confused.
I'm sorry.
You're good.
So now I have all the information I need to make substitutions.
Yay.
Integral 137 over, to find this is equal to tan theta, a tan theta. But I got a problem. I have 9x is equal to a secant theta. But over here I only have x. What should I do?
Divide by 9?
Divide by 9. So I can say that a
secant theta over 9 all squared.
squared.
D.
Yep, that'll be the easiest thing you can do.
Yeah, because 9x all squared is the same as 81x squared. You could be reading that.
And so then I'm going to do some simplifications. A over 9 I can pull out as a over 9 squared. Does that make sense?
Mm-hmm.
So like 7 over a squared times x squared times the integral 1 over secant squared theta tan theta dx.
Love seeing
Now
all
you
those
get rid of
scary
dx.
numbers. Dx, we can find the derivative of what we said was x.
And what is x?
A secant theta over 9.
So then dx would be equal to
1/9 secant theta tan theta.
what am I missing?
A times A.
What am I taking the derivative of relative to?
D d theta.
That's the whole reason we're doing this, is because we need to take this integral with an integration variable of theta. So we substitute that in for x here, dx. And we have 137 times 9 squared, or a squared, times the integral. And we can bring out this a over 9 again, so we would cancel out this and this. Does that make sense?
Oh, yas.
And this guy
I
here,
like it.
leaving us with secant theta, tan theta, over secant squared theta, tan theta, d theta, which will simplify to
1 over secant squared secant theta.
which is
Cosine theta.
theta, d
D
theta,
theta.
and the integral of cosine theta relative to theta is
Sine.
we have 137 times 9 for a times sine theta.
Plus C.
Also. And so now we need to find our x again, which we can find from sine theta. So what would that be?
So we need sine is opposite over hypotenuse, so that would be square root of 81x squared minus 9 over 9x.
And our a is 3. I'll just have this 3 cancel with this guy. So knowing a is equal to 3, we can just divide this 9 by 3 to get 137 times 3 times this guy here. Also